Okay, these are some of the problems from the Chapter 6 review, and this is number 29. And we have a second derivative here, and we're going to try to solve for y, so we're going to have to take the derivative twice, or the antiderivative twice. Excuse me. So this is our second derivative, 2x minus 1 over x squared. And I rewrote this as 2x minus x to the negative 2. X is greater than 0, and they tell me that y prime of 1 is 1, y of 1 is 0. So that's how I'm going to find my different c's. So first of all, I'll just take the antiderivative of this, which is going to make the first derivative. So I'll go from the second derivative to the first derivative. And this is going to be add 1 of the exponent divided by that. So it's going to be 2x squared divided by 2. And here I'll add 1 of that and make that negative 1. So that would be negative x to the negative 1 divided by negative 1 plus c. And then I can make that a positive. Put this in the, 1 over x plus c. And then I'll use this or identity they gave me, or this value they gave me, okay, or initial value, sometimes they call it like that, or given value. Y prime of 1 is 1, so this would be 1 when x is 1, so I'll put a 1 in every time I see an x. So I'll put a 1 in there and 1 there. And 1 squared is 1, 1 over 1 is 1, so I get 1 equals 1 plus c. That's 2. If I subtract 2, I get negative 1, so that implies that c equals negative 1. So now I know that dy dx equals x squared plus 1 over x minus 1. Now if I want to find y, I have to take the antiderivative of that. So we just have to do it twice. This is the second time. So the antiderivative of x squared is x cubed over 3. And the antiderivative of 1 over x is good old the log of 1 over x. Now we did have some stipulations up here that x was greater than 0. So we're not going to have to do that absolute value sign. I just kind of wrote it down by force of habit. Okay, but later we'll get rid of it at the end, and then minus, and the antiderivative of 1 is x plus c. And if we want to find out what c is, we knew up here that we were given that y of 1 is 0. So every time I see so I'll put y, the value of y function is 0 when x is 1. So I'll put a 1 there, a 1 there, and a 1 there. So 1 cubed is just 1 over 3 is 1/3. The natural log of 1 is what? Well, you raised to what power is 1? 0. Minus 1 plus c. So this is 1/3 minus 1 is negative 2/3. If I add 2/3 to both sides, I get c equals 2/3. So I just put that in my final function. And I get y of x equals x cubed over 3 plus a natural log of x minus x plus 2/3. And we really didn't need this absolute value sign since x is greater than 0. So you could write the answer like that. Okay? That's number 29. Nice, easy double differential equation, so not too difficult. Let's take a look at number 31. Okay. So we got. Let's actually bring this just a little bit closer. It might be a little bit easier to see. So here's 31. And then we just have a differential equation, so we have to use separation of variables. So we'll divide both sides by y plus 1, and we'll put the dx on the other side. So we'll separate the variables, then take the integral of both sides. And then we know that this is going to be the 1 over u du. The derivative of that's just 1, so we're in good shape. So we're just going to use the natural log of the absolute value of y plus 2. And the antiderivative of 1 is x plus c. And then we change this to an exponential equation. My base is e. My exponent is x plus c, and my answer is y plus 2. And this is an exponential, it's always positive, so this is positive. So I don't need the absolute value sign anymore. And then I'll break this up into e to the x times e to the c, make this a c, and put this in front like we've done before. So I got y, and then I subtracted 2 from both sides. So I have y sub x, y as a function of x, I just wrote it as a function of x. And I put the 2 on the other side. Equals c e to the x minus 2, because I moved that 2. And then we have an initial condition. When x is 0, y is 2. So we put 2 in for y and 0 in for x. And so e to the 0 is what? 1. So we just have c times 1 is c minus 2 equals 2. That's just c. If I add 2 to both sides, I get 4 equals c. Okay, so I just substitute that in for c, so y as a function of x equals, instead of c, 4 e to the x minus 2. Okay, I hope you can follow all that. I combined a few steps, skipped a few steps. I don't normally do that, but hopefully you can follow this. They should be pretty easy at this time. Okay, let's take a look at number 32. This is another separation of variables. So again, I divided both sides by y plus 1 to get all the y's on the same side with a dy and put the dx on the right. Then I'll integrate both sides, the left and the right. 1 over y plus 1 dy equals 2x plus 1 dx. If I take the antiderivative of the 1 over y plus 1, I get the natural log of y plus 1. And the antiderivative of 2x is 2x squared over 2, which is just x squared, plus x plus c. And then again, as before, I take my exponential, change it to a logarithmic, from a logarithmic to an exponential equation. My base is e, this is my exponent, and that's my answer. And again, any exponential function is always positive, so I don't need the absolute value sign. And then I can break this up again. E to the x squared plus x times e to the c. That way we can get at that constant. And then e to the c I'll call just c, and I'll put it in front. So this is the same thing as c times e to the x squared plus x. So I can put this back in. I can subtract 1 from both sides. So I get y as a function of x equals c e to the x squared plus x, and then minus 1, because I move this over. Then my initial condition was y of negative 1 equals 1. So that means I would call this 1, and I would put a negative 1 in for my x's. Okay, this is the 1, and this is the value of x it gives that. Okay, and then minus 1 because I didn't solve this. Okay, well, negative 1 squared is 1, and then minus 1 is 0, so I just have e to the 0, which is just 1. So I have c1 equals c minus 1. If I add 1 to both sides, I get c equals 2. So I put that back in, and I have my exact solution. Y as a function of x equals 2 times e to the x squared plus x minus 1. Okay? So number 32. Hope that helps. And let's try number 37. And number 37 was a slope field, and it was pretty easy because I only had one variable, just negative x, so the slope was equal to negative x. I made my little pattern over here, which you should do. And then the slope is whatever x is, so whenever x is negative 1, which are all these values over here, the slope is negative. When x is 0, when x is negative 1, the slope is negative x, so that would be positive 1. Okay? When x is 0, the slope is negative x, or negative 0, which is 0, a horizontal line. And when x is 1, the slope is negative 1, which is negative 1. Okay? So first of all, when x is 1, the slope is 1, so it's all this, just these positive diagonals. And you just draw those positive diagonals right through those little dots. And make sure that they're parallel. Okay? Then when x is 0, the slope is 0, that's easy, that's just a horizontal line. There you go, there. And then when x is 1, the slope is negative 1, so it goes down like this. I have to make sure that I get a nice diagonal. And there you go. That's your slope field, so that's not too hard. That was kind of an easier one. Okay? All right, so that's 37. Hope those help.